Let's go ahead and get started. So a couple quick announcements. So number one, your homework 4 is due today. So if you haven't already done so, you really need to upload that into that network drive at least before the end of class. What the TA is going to do is collect all of those materials, and then basically anything that has a date modified on it that's after 9:15 a.m. today is going to have a late charge assigned to it. So just make sure that you've got that in there at least before we close class today. Speaking of, one thing I did want to point out, I had a few comments last time about, and very, very reasonable comments about students wanting to know like specifically what they got deducted on the homework assignment. So we're going to do the grading for this one, and I think for future assignments a little differently. Instead of me just dumping that onto a flash drive and giving it to the TA has access literally to all these folders. So what the TA is going to do is they're going to grade your assignment, and if there's something wrong, they're literally going to leave a comment like on the file so you'll know what was deducted. So I figured that's a pretty reasonable and fair arrangement. Does that sound good? All right, yeah. I honestly, I didn't think it would work from a technical standpoint. There was a number of issues. I had a student with me when the network drive was being set up, and I think we had to try accessing it like 3 or 4 times before we even got it to work. And it was like once I got it to work, I was like, okay, let's not mess with it. It works. Don't touch it. Well, so but yeah, so I have since given the TA access to that. Okay, as everybody's filtering in, a couple other things. So today I do have to leave a little bit early, but I'll be here. But I'll try and be here for the majority of class. I have to leave around 9:05, 9:10. Although I really don't have much to lecture about today. Today's really on you more than it is on me. But we'll get into that. The only other, I guess, announcement is Engineering Career Day is going to be on Thursday as well in the Don Morris room. There's going to be a lot of potential employers and Army Corps folks and things like that. So if you got time, maybe you want to duck your head in, peek your head in, and check it out. One last thing about the attendance sheet, and I guess this might be a little bit of unpleasantness, but I figure we'll go ahead and just get it out of the way now and sort of move on. So I take attendance with the sign-in sheet, and I've gotten to the point where I kind of know everybody in the room, so I know if somebody's here or not. And last time there was a name on the attendance sheet, somebody signed in that wasn't here. So yes, I kind of noticed that. I guess the only thing is just don't do that. I know it's tempting to text a buddy and say, hey, can you just sign me in? Well, I mean, the attendance is for a grade, so don't do that. So I'll just say that now. If we have any more issues, I'll just call attendance and we'll just do that. Sound reasonable? All right, okay. I'm gonna go ahead and pass this around. All right. So today I'm not lecturing a thing. All I'm going to do, I'm not teaching anything. All I'm going to do today is talk about what is going to be on the exam, the format of the exam, so everybody understands what to expect when they come in here. And I'll let you all ask literally whatever you want. One thing before I get into the exam, though, is I wanted to at least show you this. I'm not going to spend much time talking about it, but this is the solution to homework 4. I'm not going to go into it in grand detail. I'm actually going to go through it very quickly in case some of you are still chugging some things out here and there. But suffice it to say, let me not save changes to that. Suffice it to say, everything will be on MU Online at 9:15. Okay, so I'm not going to go into it in significant detail because I know that you might be tweaking some things here and there, and I honestly don't mind that, but I just wanted you to know that at 9:15 it will show up on Blackboard. So you will have a copy of the solution to study between now and Thursday for the exams. Does that sound reasonable? All right. Let's get into the exam and specifically the exam review. Now, was everybody able to access the lecture review slides over the weekend? Did anybody at least take a look at it? If not, no biggie. I mean, that's what we're here today for. So let me go through the specifics of the exam so that everybody understands what the exam is going to be about and what it's going to cover. Okay, so first off, the exam is going to be closed notes. So I'm going to turn off all of the links on Blackboard temporarily. I don't think it would matter anyways because I'm going to be walking around, so I mean, I don't know, you're going to be able to check the notes anyways. But also, I don't know that you would really have a significant amount of time to sit there and study the notes, find that one formula, and use it on the exam anyways. I mean, if you sit there and just do the exam, you'll have plenty of time. But if you're trying to, if you're not really learning the material, you're having to refer to the notes for every single little thing, you'll probably be a time crunch. So you won't be able to use the notes, but as a, I don't know, say show of good faith or you know, one hand washing the other, whatever you want to call it, I am going to provide any relevant formulas I think that you need. So like, for instance, the linear interpolation equation. I'm not going to make you memorize that. It's on there. So you don't, I'm not, that's not what I am. I'm not a memorization guy. I want you to be able to use the methodologies, not memorize them. I don't really care about memorization. Okay, now try and be on time. I know a couple of you were filtering in a minute or so late, and that's no big deal, but you know, Thursday's exam time, so really do try and be on time. I mean, if you're late, it's just going to hurt you. It's not going to hurt me. So we're going to start at 8 a.m. on the dot, okay? Now, if you need scratch paper, if you need a stapler, we'll have it, but there really should be plenty of room on the exam to do the work, so you really shouldn't need any extra materials. As for the areas of coverage, Lecture 1 to Lecture 12, and I guess maybe I should add Homework 1 to Homework 4, you know, the last four, all the homework we've done up until now. Maybe I should add that. All right, let's talk about the administration of the exam, how it's going to work. So there's going to be two parts to the exam. So the way to work is at 8 o'clock on the dot, you will begin Part 1, and everybody will be doing Part 1 by hand. As soon as you finish it, if it takes you 5 minutes, if it takes you 30 minutes, whatever, as soon as you finish it, you turn it in, I'll give you Part 2. Okay? The reason why it's split up into two parts is because Part 1 is what I call a pencil to paper computations exam. It's literally just a pencil and the Casio. That's all you've got. But as soon as you turn that in, you'll have an Excel-based exercise for Part 2. Okay, so for Part 1, you're only allowed a calculator, only allowed a pencil, but on Part 2, you can use the calculator and you can use Excel. Sound good? All right, now, what I have here is on Part 1, there's going to be roughly 8 to 10 questions on Part 1 that kind of covers all the basic computation stuff that we've done throughout the semester. You're allowed to use the Casio and a pencil. Now I have here on Part 1 a maximum time limit of 45 minutes. And the reason why I'm putting a cap on it is because I don't want you to spend an hour on Part 1 and not have any time at all to do Part 2. I want to give you a fair shot of getting both parts of the exam done. Now, what I tend to do when I make exams is first off, I'm not a time crunch exam guy. I'm not the guy that will give you a 6-hour exam and give you half an hour to do it, and the exam becomes a test of not how well you know the material, but how fast you can hit buttons on a calculator and how fast you can write. That's not the type of exam that I like to administer. So I tend to use a rule of 3. So to give you an idea, if it takes me 5 minutes to do the problem, it ought to take you 15 minutes to do the problem. I like to use a rule of 3. And Part 1, I did Part 1 in about 10 minutes. So I'm giving you a maximum time limit of 45 minutes. In my opinion, you've got plenty of time on Part 1. And me calling it at 45 minutes is not to penalize you, it's to give you an honest shot to do Part 2 as well. Does that sound reasonable? Sound good? Okay. So for the Excel exercise for Part 2, what's going to happen is this. You're going to log on to your computers and log on to Blackboard, and there's literally only going to be one file on Blackboard. It'll say, Exam 1 Part 2, and it will be an Excel file. You will download that Excel file, and then you'll be given instructions on take this Excel file and do stuff to it, calculate some stuff, plot some stuff. Take that, and when you're finished, upload it to your network drive, and that's it. So does that sound reasonable? Okay. Now, as for what topics are going to be covered on the exam, I know this seems like a lot, but if you start breaking it down, it's really not that bad. So, for instance, the fundamentals, make sure that you recall, engineering prefixes. If we put a kilogram on there, make sure you know what kilo means. Order of magnitude estimates, make sure you at least know how to do those. Make sure you understand scientific notation. Make sure that you can correctly express values according to significant digit rules. So if it's addition and subtraction, make sure you're expressing based on the least common digit or the last common digit. And if it's multiplication or division, make sure you're expressing based on the least number of significant figures. Make sure you can handle units. You know, you're expressing an answer in appropriate units, and you're able to perform unit conversions. So if I ask you how far it is from here to LA, you do not express that in millimeters. That doesn't make sense. You know, make sure you're expressing it in miles or kilometers or something like that. Make sure you can do linear interpolation, and make sure you can interpret pseudocodes and flowcharts just to have an understanding of what's going on. All right, for the Casio, make sure you can just use it. Make sure you can do basic computations. Make sure you can convert between rectangular and polar and vice versa. Make sure you can manipulate quantities that are in degrees, minutes, seconds. Make sure you can use the calc mode. Make sure you can use the solve mode. And finally, make sure you can use mode 5 and mode 7. Mode 5 was that equation solver that had those pre-built equations in it. And mode 7 was the table command. That's what you use to plot, or you create a table of values for plotting. Lastly, for Excel, make sure you can perform basic computations. Make sure you understand the order of operations in Excel. Make sure you understand the difference between relative addressing and absolute addressing. You know, those dollar signs and F4. Make sure you understand how to do that. You got to be able to plot. Make sure you can generate basic charts of data. And make sure you can also do formatting of those charts. You know, put an axis title on there. Change the range of the axis. Put a chart title on there and all of that. Just make sure you can do basic formatting of charts. Make sure you can fit a curve. Use that trendline command to make predictions. And finally, make sure you can use goal, seek, and solver. And that's it. That is exam 1. Okay. So what I like to do now is I like to shut up and let you all ask questions. Now, before I do want to tell you a pearl of wisdom from the professor's perspective. You know, I've done a number of these exam reviews in my careers. I know that there's times when the students are nervous about asking questions. I guess they're afraid they don't want to sound foolish in front of everybody else. Well, let me tell you something. What ends up happening is as soon as somebody raises their hand and asks a question, like half the class has this look on our face like, yeah, I wanted to know the answer to that too. So please, if you've got a question, I mean, now's the time you can literally ask whatever you want. I mean, you can ask me what the answer to problem 1 is. I won't tell you, but you can ask. So, so with that, yes, sir.
Can you give like a basic example of when to apply the calc function and solve function for Casio?
Okay, no, that's a good question. All right, so first off, let me go back to the notes that were relevant to that. So I am recording, so I'm going to try and repeat the question so that everybody hears it on the recording. So the question was an example of when to use calc or when to use solve. Okay, so let me find the notes that were relevant. I think that was right here. Okay, so the calc function, I would say the best use of the calc function is if you have some value or some quantity that you want to compute over and over again. So let's say I've got the quantity 3a plus b, and I want to do that 3a plus b over and over again for different values of a and different values of b. So what I can do using calc is I can say, all right, let's just literally type in 3a plus b. Like that's what I want to compute. And then using the calc function, what I can do is I can say, all right, now that I've got that defined, plug in a value for A, plug in a value for B, and it'll do the math. Now, 3A plus B, that's simple. But if you've got a really, really long expression, and you're doing it over and over and over and over again, it might behoove you to spend a little bit of time actually typing it out once, and then just changing values over and over again. So calc is used for repetitive computations, for if taking a complex expression and doing it over and over again. Now, solve is used to literally solve an equation. So if I've got something like y equals ax squared plus b, and I know everything else except x, okay? So I'll plug in a value for y, plug in a value for a, plug in a value for b, and I'll solve for x. The nice thing about the solve command is that it will solve anything. For instance, if you go to mode 5 in the Casio, Mode 5 only has 2x2 equations, 3x3 equations, and quadratics and cubics. But solve will handle anything. The downside is that you have to provide an initial guess. So I'll plug in a value for A, plug in a value for B, plug in a value for Y, but when I solve for X, I got to guess something. So it kind of works like, remember last time when we did goal seek and we were looking at the trajectory of that projectile and we said, okay, what's the angle need to be to hit a certain distance, and we found there were two answers? Well, the answer was contingent upon our initial guess. The same thing's kind of true here. So, you know, I'm guessing the solution to this equation, or my initial guess in this case is x equals 1. And I go through and do the math and it gives me an answer of 1.414. But if I guessed a different value, I might have gotten a different answer, especially for something like a quadratic that's got multiple answers. Does that sort of help? Yeah. All right, that's good. And does that clarify for everybody else? That's good. Okay, so I really, this is the type of stuff that's important, because this is another thing. You asked that, and I saw a couple people go, yeah, I wanted to know that too. Yes, sir?
You're going to ask for bilinear interpolation?
It's possible. I'll say that. The question was, is a bilinear interpolation problem going to be on the exam? And I'll say it's possible, but it is much more likely that a just straight linear interpolation problem will be on the exam. But I won't give you a yes or no on that. I'll do, like I said, I will do my best to answer some of these questions. Some of them I gotta play a little close to the chest. Anybody else? Yes, sir.
What's the answer to number 2?
What's the answer to number 2? Now, yeah, that was a nice try. Can't do that one. Yeah, you, and then somebody else raised their hand. Who else raised their hand? I saw somebody else. All right, go ahead. That's a great question. The question was, is it going to be clearly indicated when significant digits are important or not? And the answer is yes. Okay. I've gone through the exam a few times and I've done my absolute best to remove any ambiguities. For this course, I don't really think that's appropriate. Now, let me be frank. If I was teaching something like steel design or concrete design, I'm probably going to be less apt to just say, you know, sort of spoon feed the format of the result that I would like. But in here, you know, we could do a computation, and then depending upon, do I want this number of significant digits, or do I want it in scientific notation, or do I want this many decimal places, I could get different answers. And I don't want you to get hung up on not knowing what you would like this guy to have instead of not knowing how to do the problem. You see what I mean? I would rather you spend your brain power on the exam on how to do the computation, not, well, what's going to make Dr. Michelson happy? You know, so I think I've done a pretty good job in removing a lot of that ambiguity. That's a great question. Did that answer that? All right, good. Anybody else, please? This is the time.
Last Excel homework.
Last Excel homework.
Fitting trend line
Mm-hmm.
to chart. How do you get it to fit and show the equation and you use the equation? Because I displayed the equation, but I had to punch it in manually to get an answer.
Okay, so the question is, if you've got a trend line on a chart, how do you use that equation? And for the purposes of that homework and what we're doing on the exam, the answer is you would just punch it in manually. And that's absolutely right. There are some native Excel commands that you can use to actually reference that equation. For instance, how many folks have had a course in statistics? Or okay, you're in one now. So when you take statistics, one of the fundamental tasks that you learn, and this is relevant to your question, is how to do linear regression. So you're given a series of data points, and then the question is, based on this data points, what's the best fit line? And to fit that line, you need two things. You need a slope, and you need an intercept, right? Y equals mx plus b. There are commands in Excel, like there is a command in Excel literally called slope. And you hit equals slope of, and it asks you for what are the y points and what are the x points. And then when you hit enter, that cell literally contains the slope of that best fit line. So you can do then what you're talking about, which is reference that equation. It's easier to do for linear, I would say. When you've got exponential or logarithmic, it does get a little trickier. So I totally understand that. Yes?
In the interpretation of pseudocode, do we need to know what each different geometric shape means?
So the question was, in the interpretation of pseudocode, do you need to know what each symbol, or the flowchart, what each symbol means? And I'd say no, but I do want you to know that the diamond pattern means a decision point. That's like, if I get to a diamond pattern, I have to make a decision. Yes or no, 1 or 0, left or right. So I do want you to understand that. Now I will say, I'll just go ahead and be honest with you, that will become much more important on exam 2 when we actually start writing programs and developing our own code using MATLAB and things like that. Yes?
Will there be unit conversions that weren't on homework 1? Because I didn't know what
No,
on homework 1.
That's a good question. So the question was, are there unit conversions that weren't on homework 1? And in general, what I'll say, the answer to that question is no. But I will also say that any unit conversions that you need to be able to do, you will be able to do with the Casio. I won't spit something out like, convert to kips if kips literally aren't on the Casio. Then you're like, what the heck is this? Because I have to recognize that, okay, there's many people, most of you haven't had, statics or civil engineering materials or structural analysis. So, like for instance, the kip. If you're a civil engineer, the kip is one of the most fundamental units that we use in civil engineering. But if you haven't had these courses, this might have been the first time you ever heard of it. So, and I totally understand that. So I'm not going to do that. I'm not going to expect you to memorize things that you wouldn't have been exposed to. Now, I will say that it is very highly possible that I give you a problem similar to the ones where I would give you a formula and I give you some units and then you have to determine whether or not it's dimensionally equivalent or not. That's very possible. And in that case, I could give you something like a liter or a kip or an ohm or whatever, because the point is not to take a unit and convert it from one value to another. The idea behind that problem is literally just plug and chug and see if it matches what it should. So that is very possible. All right. Does everybody understand that? Good. Yes, sir.
In that scenario where you talk to sound like F equals whatever.
Let me say, in that scenario, what would be more appropriate to say, well, if I have x in the equation, x is a distance, so that needs to be in inches, and that will be there. I'm not going to expect you to know, like for instance, in fluid mechanics, I'm not going to expect you to know that gamma is a unit weight. That would be newtons per cubic meter. You wouldn't be expected to remember that because you're not in fluid mechanics. You're in engineering computations. So in that scenario, I would tell you that's what gamma is. It's a newton per cubic meter, something like that. Absolutely. Great question. Everybody else okay with that? Yeah, and this is the time, so I mean anything you got. Oh, we got plenty of time. Yes, sir.
If you have a significant figure problem and you have something like kips, do you go by the amount of kips or the amount after you convert it?
Okay, so the question was if you've got a significant figure problem and you go by kip. So just so I understand your question, you're asking before and after unit conversions, where's the significance? What I tend to do is this, is before I actually do the computation, I try and get everything in consistent units, okay? Then I perform the computation, and what I do my best to do is to try and refer to the least precision off of the original input. And I'll say this, you're actually talking about what I would call a little bit more of an advanced topic in the world of engineering, because if you are trying to compute the strength of that column and you've got inches and pounds and all these different units, and then you got to convert it, and that's the thing that sucks about the American or the English unit system, is that the unit conversions aren't nice, pretty intervals of 10. They're nuts sometimes. So it gets kind of tough, managing that level of significance. What I'll say is this: in later classes, when we take like steel design or concrete design, we usually just right off the bat just adopt, like, let's just round everything to the 10th place or something like that, and then that just sort of washes that out a little bit. On this exam, I'll just go ahead and say those ambiguities are not things you've got to worry about, especially with U.S. conversions. Because if you're trying to convert from U.S. to metric, I mean, you've got these conversions that are like 3.048, and the significance gets a little strange. I understand that. That ambiguity is not something I'm worried about on the exam. If it was purely an SI exam, then that question that you're asking wouldn't really matter, because that's one thing that's nice about SI units is all the unit conversions are tens. You're just changing your decimal place, so we don't have to worry about that. Does that answer your question? Yes, sir. What's that?
Will there be parts for each question, like part A, part B, part C?
Okay. The question is are there parts to the questions? And the answer is, in some cases, yes. In some cases, no. The questions in my mind, like each question, for the most part, is it references the same amount of grunt work, I would say. Now, for instance, if I have a question where I just say do some computations, I might have you do 3 or 4 of them, so like 3 or 4 different ones. That's in some instances. In some instances, I might be asking you a question that requires a little bit more work, and then there isn't a part A, part B. To supplement that, what I'll say is this. Every single question on the exam has a point value next to it. Every one. Okay? I'm not going to be ambiguous in terms of how much each question is worth. You will know, looking at it, this question's worth 5 points, this question's worth 10 points. So I should probably spend a little more time on this one than I do on that one. Is that a fair point? But the simplest answer to your question is, in some cases, yes, in some cases, no. I can't really say any more than that. Does that answer your question? Yeah. Everybody else? Okay. Anything else at all? Anything? Yes. Great question. Do you need to conduct yourself that engineering format to problem statement and givens and no? The answer is no. Literally, here's the problem. Here's space to work the problem. Just do the problem. And there's a slot on each problem. Like it'll be very clear. Like here's where you put the answer. So I think that would be the only thing I would ask in terms of format is put the answer where it says to put the answer. I know that seems. Of course you put the answer where you put the answer, but I fully understand that during an exam you might just be doing the calculations and you finish and you just move on and you leave the answer spot blank. Just that's all I would ask is put the answer where it says answer. So, sound good? Y'all nervous about the exam? Can't wait? I mean, it's a celebration, right? Just we don't have exams in college. I keep calling it that. We have celebrations of learning. So. You civil folks, you're going to get tired of that joke because I say it quite a bit. Anything else? I want you going into the exam relaxed. I don't want you freaking out about, oh, what if he asks this? I want you to very clearly understand what's going to be on the exam, any concerns you have about anything. No matter how crazy or wild the question is. Yes, sir.
To be able to express things perfectly. I remember homework 1, when we had variables and they were like in their units, we have to do that and be able to say, do they equal each other on the side? Like, do these both equal newtons on one side?
Okay, yeah, the question was, do you have to be able to assess whether or not an equation is dimensionally equivalent? And I will say the answer to that question is yes. Okay. What I will say though is I'm not going to incorporate a off-the-wall unit that you've never seen before, or a problem where you need to do multiple unit conversions just to get everything identical. I will admit, that problem that we had on the homework assignment, you had to know that 1 Newton equals 1 kilograms times a meters per second squared. Okay. What I will say is that point of confusion is eliminated if it's going to be on the exam. I'm not going to do that. But on the flip side, do you need to be able to do those types of computations? Yes, you do. Okay. Does that kind of answer your question? But yeah, I'm not going to have that intermediate conversion like I did on the homework, where you had to, say, take this Newton and then do this, then plug and chug. That I won't do. Yes, sir.
Can you do an example or two of relative?
Okay. Tell you that so the question was doing an example of relative and absolute addressing. I think probably the best way of going about that is to actually use this, because one of the things I didn't do when we had when we went through our notes is I kind of just did something on the side. I didn't really actually follow the example that's in the notes. So since we're talking about it, I've got the example in the notes. Why don't I do this? So let's look at this example. Okay, so I have here a bunch of numbers typed into some cells on a spreadsheet. So I've got, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. And I enter in a formula right here. Okay, so the formula that I enter in is this. It's 1. Oh, my pen's messing up. All right, well, I guess I'll just have to use my hands. All right, so the formula that I'm entering is 1 plus B5 times 2. Okay, so it's that formula right there. Okay, so in this cell right here, that's what it's entering. So it's essentially saying 1 plus whatever is in this cell times 2. Sound good? Now, if I take this formula and copy it down to some of these cells right here, this is a perfect example of relative addressing. Okay? Okay, and here's the easiest way to explain that. So this cell contained right here, this one with the 5, it contained the formula 1 plus B5 times 2. Okay? Now that's that cell. Okay? If I take this cell and copy and paste it down, this is a perfect example of a relative address. The first formula had the reference B5 in it. Everybody see that? Well, if I copy that down, the reference goes down as well. So instead of referencing B5, like you can you can almost sort of keep your fingers literally pointed on the sheet and say, all right, this is going down B5, copied down, it's going to reference B6. And it's referencing B6. So B6, B7, B8, B9. Does that make sense? Okay. Now that's relative addressing. Absolute addressing would be, well, let me also do this. Here's another case of relative addressing. So if I take these formulas and copy them over here, if they're originally referencing B5, then they'll reference A5 or B6, A6, B7, A7, and so on. Everybody see that? Everybody okay with that? All right. Now what happens here with absolute addressing is, here's the idea with absolute addressing. Instead of moving that reference down as I copy and paste the cell, the idea with absolute addressing is that it doesn't move. Okay? I mentioned this example when we started doing projectile motion. I might be doing a boatload of calculations, but let's say in this one particular cell right over here, I have the acceleration due to gravity. I got negative 9.81 meters per second squared. Well, I'm going to be doing calculations all over the place, but that value isn't going anywhere. Okay? So let's say that value is in cell C5. Okay? If that value is in cell C5, anytime I reference C5 throughout the sheet, I might lock it. I might say, no. Anytime I copy and paste that formula, C5 is locked. I have $C $5 because that's where I've got gravity. Gravity isn't going anywhere. All right? Does that make sense? Everybody okay with that? So that's a perfect example of absolute addressing. Another example of absolute addressing is something like this. If I'm trying to do a running total of a given set of quantities, let's say on Monday, Tuesday, Wednesday, Thursday, Friday, I have written down how many samples I've collected, or maybe this is how many miles I ran on each day. So I ran 5 miles on Monday, 6 miles on Tuesday, 2 miles on Wednesday. I was having a lazy day on Wednesday, and 4 on Thursday, and 3 on Friday. A running total would be, as the week goes on, how many miles have I run total? On Monday, I've only ran 5 miles that week because I've only ran one day that week. Now, if I run 5 miles on Monday and 6 miles on Tuesday, well, I've run 11 miles for the week, right? 5 plus 6. And if I run an additional 2 miles on Wednesday, there's 13. And then 2 miles on Thursday, that's 17. Does that make sense? Everybody okay with that? So the idea behind absolute addressing is I might be saying, all right, as I copy and paste this cell down, I want to take the sum. So like this one right here would be the sum of these two. And this one down here would be the sum of these 3. And this one here would be the sum of these 4. And this one would be the sum of these 5. Everybody see that? So as I copy and paste down, what I want to have happen is I want the range to sort of do this, right? If the range is, let's say on this cell, if it's from B2 to B5, I want the B2 to sit still, but I want that second one to go down. So see how I've got this right here? See how the first cell is locked. So as I drag that down, that first cell isn't going anywhere. But the second one copies down. Right? Does that make sense? Now, does that kind of answer your question? I want to make sure I answer that. Everybody else okay with that? This is good. So I really want to clear that up. Everybody good? Yes.
Wouldn't you just lock in column B and not 2? Because that would just leave that 2, wouldn't it?
That's a good question. So wouldn't you just lock in column B or what have you? First, okay, so the answer is you wouldn't lock in column B. You could also lock in, hold on, let me answer it like this. So you agree that this works, right? Okay. So the question here is, are there any extra dollar signs that I removed? Now, what I propose is this. You're saying that we can leave it on column B. What I'm saying is we can leave it on row 2. So instead of locking in, instead of having $ B2, I'm saying it's B $2. We can lock in the row and not the column. Let me pull up an Excel sheet to kind of explain. So 5, 6, 2, 4, 3. Okay. So we had equals the sum of that, right? And if you hit a colon, it'll automatically do that. Now, the Excel sheet or the PowerPoint has this. So I have the first cell locked like that, right? And if I take this and I double click, that fills that in. Sound good? Now, what you're saying is this. You're saying that what I can do is this. So are you in agreement? This is what you're saying? Okay, now, here's the problem with that. You see what happened? Okay, what happened is it's locking that column in, but it's not locking the row in. I propose that what you could do is this. Okay? Instead of locking in the column, I propose locking in the row. And here's why. All right? First off, let's drag this down. Okay? And let's look at, let's say, this one. Okay? Now, I propose, as I drag this down, what I want to sit still is this reference right here, right? So it's going to be B2, B5, B2, B6, or B2, B7, B2, B8, B2, B9, B2, B10, right? And I propose what's sitting still is not the B, it's the 2. Everything is referencing this first row. You see what I mean? Does that make sense? Is everybody else okay with that? This is important stuff. So in that instance, we would lock the row. Let me also say this. If I was going in the opposite direction, dragging the formulas this way, like let's say it was like this. Let's say it was, here, let me delete all this. Let's say it was like this. Let's say it was like that. Okay? What I could do is I could equals the sum of this, but instead of locking in the row, I proposed in this instance, we can lock in the column. Now, if I take those formulas and drag them this way, it works. Because again, if I look at this one, look at that address. I'm going like from B to C, B to D, B to E, B to F, B to G, right? It's the B that stays locked, so I put the $ in front of the B. Does that make sense? Is everybody else okay with that? That's sort of a really important concept to understand. How those relative addresses work if you take a cell and copy it from one location to another. That's pretty important.
You won't have anything you can set diagonal with that. It'll just be vertical or horizontal across.
That's a good question. So the question is, will you have any references that'll be diagonal or horizontal? This is what I will say. Okay. Do you need to understand the difference between relative and absolute addressing? Yes. Do you need to understand how that works when you're doing part 2 of the exam? Yes. Do you need to understand how that works on part 1 of the exam? Yes. But what I'll say is this. On that homework, we had formulas that had like 8 or 9 terms. Like it was nuts, right? That I will not do on the exam. Right? If I have a relative or absolute address problem that you need to do by hand, it will be manageable. It won't be huge. That I'm not doing. Because in my opinion, if you understand relative and absolute addressing with 2 or 3 cells, you understand it with 20. It's just a bookkeeping issue at that point. It doesn't, in my opinion, it doesn't examine your understanding of the topic. Now I'm just being a jerk at that point. And I do my best to not be a jerk. I'm a nice guy most of the time. I just have really bad, cheesy jokes. I mean, you know. I will get you all out of your shell. It will happen. There we go. We're getting some laughs. That's what I like to see. Right. Any other questions? This is good stuff. I know some of the other review sessions have only lasted like 15, 20 minutes. I'm liking this because that means you all are getting your money's worth. The sign-in sheet not make it on this side? Ah, goodness. Come on, guys. I usually blame the first person that says not me, so I'm like,
Should have known. So, how do you save this shenanigans in Excel? I can't get it.
all right, hold on. Let me answer his question, then I'll answer yours. All right, hold on. Everybody needs to see this. First off, let me be clear. This is on Blackboard, so if you miss, I mean, it's literally right there, but I'm going to show you how this works again. So you right-click, hit Run, and you hit / Site CS right here. Okay? Now, when you hit OK, it should pop up a folder looks something about like that. Let me see. Let me try. Let me see yours. Oh, did I say the wrong slash? Oh, yep, it's that one. Try that. Slash going the wrong way. There you go. So go to class. First, it is sort of foolproof. You're only allowed to access literally your folder, and that's it. But you can go to Classes, Engineering 111, and since we are recording, I'll keep everybody's username off here. But you can open that, and you can literally navigate to your file and open it. You can't open anybody else's. So you could put this on a flash drive while you're working on the exam or save it to your V drive. When it's done, just literally hit copy paste and copy and paste it into your folder. You can just whatever name is on Excel or on Blackboard, just save it the same name. As long as it's in your directory, you know, I'll know whose it is. Sound good? Now that the TA has access, he can literally leave comments on your particular file so you'll know what he deducted last time. I didn't do that on homework 3 just because it was sort of touchy getting the network drive to work to begin with. So once it got it working, I didn't really want to mess with it. So, but it was a really good point that the students made, or that you all made. So now you all can see what you did wrong. Sound good? Plus the solution to all these homeworks are on Blackboard. So. Anybody else? Anything at all? Anything? Anything at all? Yeah, oh yeah, I tried, sorry.
This is a silly question, but will we be allowed to like check our computations that we do on our calculator and solver, or the computations that we do on Excel by hand? Because sometimes we
Yeah. All right. So the question was, will you be able to, on part 2 of the exam, will you be able to check what you're doing in Excel by using your calculator? And the answer to that question is yes. I have no problem with you using your calculator on part 2. Okay? No problem with that at all. In fact, it even says on the cover page of the exam, you are allowed to use a Casio or equivalent calculator, pencil, and Microsoft Excel on part 2. So you can do that. There's no problem with that at all. If you're independently checking your own work by doing the computations again, it's like I've taught y'all to be engineers or something. So I'm okay with that. I'm not kidding. That's a good thing. Checking your work. I would prefer that when you design bridges and my grandma drives over them, that she doesn't fall in the river. So if you're checking your work, I'm all right with that. I don't want to fall in the river either. Any other questions? Come on. What's wrong? No, save it like in your V drive, and then literally just copy and paste the file when you're done. Try that. If that doesn't work, we can look at that here in a little bit. All right. Any other questions? Please, anything at all? Everybody looks like they sort of exhausted. There we go. We got one more. Yes.
If we make a table and it's fairly obvious,
Okay. All right. This is important. The question was, if you've made a table or series of calculations in Excel, will it be fairly obvious if you've made a mistake? Yes. I'm going to say yes, because what I will say is this. I think that the exercise that you are going to do in Excel is representative of a real-world problem. And I think that you can just look at it and see whether or not it's right or not. I'm not saying any more than that. Oh. All right. Any other questions at all? Anything? Please. I want you to feel comfortable on the exam. Yes, sir. How long do you expect the Excel portion to take? It depends. Let me say this. It depends on your proficiency with Excel. I, again, use a rule of 3. And, I mean, you got to understand, I was able to finish the Excel portion in well under 10 minutes. Well under 10 minutes. Now, if I just apply a conservative rule of 3, that puts it at 30. And I think you can do it in 30 minutes, no problem in the slightest. That's one of the reasons why I'm cutting off part 1 at 45. If you're spending more than 45 minutes on part 1, there's probably something, like, I mean, you might have some other issues. And the reason I'm stopping you at 45 minutes is I want to give you a good, honest chance on part 2. I fully believe every single person in this room can do part 2 in 30 minutes. Because one of the things about part 2, I'm not asking you to create something from scratch. There is a file that you are given, and I'm asking you to compute certain things associated with it. All the, format and layout, that's all done. I want you to be able to do the computations. We'll talk about specifics on formatting and how to do, we'll probably have an assignment just on formatting later. Right now, I give you a problem. I give you the Excel sheet. I want you to do some computations on that sheet. Does that sound reasonable? Question was, if you finish the part 1 early, can you start part 2 early? The answer is absolutely yes. I fully expect that 20 minutes into part 1, most people have already handed it in. Really. 20, 30 minutes in. I mean, I imagine that you're probably going to spend more time checking your work on part 1 than actually doing your work on part 1. That's just me, but I mean, the exam has a number of questions, but I don't think it's a particularly long exam. Anything else? All right. If you need to do that, the answer is yes. The question was if you have like a projectile motion problem or something similar on part 2, will you have the equations? If that's what you've got, the answer is yes. If that's what you've been given. I remember when I was in college, I'd have exams. They'd just say the exam's on Thursday. That's it. So. Anything else? All right. I'm going to do it. Hold on. You good? You good? You good?
Bother you in your office hours if you need to, right?
I'm around. I'm around. Now, 2:30 in the morning on Thursday, I think I'm going to call it. I need sleep. You good? You got a question? All right.
It's about like the class started tonight, so I need to get the records from it. I got to put this in.
All right. Well, we can look at that specifically here in a second. The only thing I'll say is you probably need to make sure you've got the right references locked up here, and that when you're calculating it in terms of x, you're using these time values, not that one. Because you're trying, I can tell you right now what it is that's wrong, because you're trying to calculate it for a given value of time, so you need to reference that time here. All right. You good? You good? You good?
No.
What's up?
This stupid thing, I can't.
All right. We'll look at that here in a second. You good? You good? You good? You four good back here? All right. If that's the case, I think I'm going to call it. I'll hang out for a few more minutes and then I'm going to bounce. If you're good, I'll see you on Thursday.